Hey everybody, today we're going to jump in. You can see the title on the screen. We are going to be multiplying binomials. Today is going to be a very mechanical day, and really what we're going to look at is trying to increase our operation ability within algebra. So we're going to add to that multiplying binomials, and then pretty quickly we're going to extend that today. So I want to jump right in and get going. Here we go. What you can see up on the screen right now is a number of algebraic expressions. And what I would like you to do is to pause the video and work your way through those four problems. Okay, this is going to be some expressions that are going to bring back some review on quite a few topics. I want us to be able to get a gauge of where we're at, but then also to use these four problems to show us where we're going. So I want you to come up with some simplified expressions or fully simplified expressions for the four you see on the screen. Let's pause it now. Okay, we are back. So as we're working our way through those four problems, I'm going to just go through and put up some solutions to them and make sure that we're good with some simplified operations. You can take a peek at the first one, and you'll notice that we are adding two expressions together. I'm adding 2x plus 3 with 5x minus 7. And so when I add those two things, I can see that I will have a 7x in total and a negative 4. Now, you may have put in a line beforehand because maybe with your background, you have the idea of in order to get rid of those brackets, you may be expanding some ones into those brackets. That's fine. So if you had the green line, then we should be able to see that that green is going to collect to the orange. Nice. Okay, I want us to take a look at B. I'm not going to put in the green line to begin with. I want to go straight to my orange fully simplified expression. You will notice that we are now subtracting two things. I am taking 5x minus 4 and I am subtracting 7x minus 11. So when I go through and I take my x terms and subtract them, I'm going to have my 5x minus my 7x, which is a negative 2x. And now here's where we got to be very careful. I have a negative 4 and I'm going to subtract a negative 11. So I am subtracting that negative, so I'm really going to add it. So my negative 4 plus 11 is going to get me to my positive 7. If you viewed that one as an expansion problem, then we may have put in the green line. But as I mentioned before, I hope we can jump straight to that orange. Okay, you take a look at A and B, and that's just us adding and subtracting expressions. So notice that would be like us going back to grade 1, and we're going to learn how to add and subtract some numbers. Okay, we take a look at C, and now it's like we're graduating to grade 2. And when we take a look at C, we're going to now multiply values. We're going to multiply numbers. So that would be an expansion problem for us. And in order for me to multiply my x by my 2x plus 3, I need to make sure that I multiply it by the whole thing. And we should have come in on the orange. We can see the same thing with D. I just want us to recognize that D becomes a bedmass question. So for us now, we're starting to mix up operations that we have in our expression. I'm going to circle them in pink. You see that you are subtracting, so we've got two terms in the expression, but that second term contains my multiply. I don't see anything between the 2 and the bracket, so I know that that means multiply. And so in terms of bedmass, I know that I cannot touch that subtraction until I do the multiply. So now I'm going to expand my negative 2 into my brackets to do the multiplication operation. And now I have an expression that will collect in order to simplify, and we come in with the orange. So I want you to take a look at those four problems and just notice that really what we're doing is we're working our way through a progression of operations. If you look back up to problem A. I'm going to circle it in blue. We reviewed adding a couple things. In B, subtracting some things. In C, multiplying some things. And then finally in D, a mixture. So I want us to have a good perspective of where we're coming from. You have the ability to do operations in algebra. I might just argue that it's limited ability. We may not have the ability to deal with anything thrown in front of us in terms of operations. So what we're going to do today is we're going to add in some more operations or make some familiar operations a little uglier. That is, we can start to deal with some bigger expressions. Okay, let's take a peek at the next one. I want you to take a look at E because E is where we're going to go with our theory today. And what I'm going to do is I want you to kind of look back at the 4 previous problems that we just did. You'll notice we were good on add, good on subtract, good on multiply, and good on a mixture. But now when I throw in E, E may cause us a problem. And the reason why E may cause us a problem is because we're making our expressions a little uglier. I want you to put in your head that what we're doing is we're making our expressions bigger. So I'm going to go through and I'm going to pop up this problem that we saw in question C. That problem that we had was x times 2x plus 3. And I'm hoping coming out of grade 9 that we are very comfortable with expanding brackets. Expanding meaning that we're good with multiply. Except your background coming out of grade 9 was that you always had one term that you were multiplying into multiple terms. It always started with what you see in the front underlined in green, that being one term. Now, the more that I can get you to look at that gold and almost view it as you are good with multiplying in algebra when you have a 1-digit number and you are going to multiply that by a 2-digit number. The more you can start to look at that as one term times 2 terms is like 1 digit times 2 digits, then you'll really understand what we're introducing today. I want you to take a look back at E. Because what E becomes for us then is now a 2-digit times a 2-digit. We're really not dealing with anything more complex than the fact that you're going to learn how to multiply bigger digit numbers. So I'm going to erase what you see in the top right corner because what I want to do is I want to walk through the fact that you're already okay to multiply 2 digits by 1. So I'm going to put up in that top right corner just a 2-digit number times a 1-digit number. And we'll make the numbers nice and easy. There's my 34 times 2. And I'm going to put up like that old-fashioned multiplication algorithm. Really what that is, if we were to go through and multiply, is that we should be good that you need to multiply that 2 by all the digits, your place value, in the 34. So you would multiply the 2 times the 30 to get a 60. You would multiply the 2 times the 4 to get an 8, and we would add those together. Now, you may not multiply that way, that you may have instead, and I'm going to erase the gold, did the 2 times the 4 first. 2 times the 4 is 8. Put down a 0 because we're about to multiply into the tens column. 2 times a 3 is my 6, so there's my 60. Now you added them together. That may have been your algorithm. I want you to recognize that in both cases, what we are doing is we are multiplying the 2 by all of the digits in the 34. And then we collect them. Well, I also want you to recognize then that is us expanding. That is us multiplying. So all I'm going to do today then, if I get rid of that problem, is I am going to make my numbers a little uglier. That maybe now it's going to be 35 times 12 as opposed to just times 2. Can you see in the green that you have a 2-digit number times a 2-digit number? And so what our algorithm becomes for that then is we need to be able to multiply all parts of my one number to all parts of my other. So if I was to go through the green problem, then perhaps our algorithm would look like this. I'm going to take that 2 and I'm going to multiply it by all of the 34. So maybe 2 times the 4 is 8 and 2 times the 3 is 6. There's me doubling 34 to get 68. Well, now I'm going to move to the 1. And the 1 is really a 10. So I got to put my 0 down to hold my place value. And now I could take that 1 and multiply it by all parts of the 34. There's my 4. There's my 3. And in the end, I'm going to collect that. And so when I collect that, I'm going to add together or combine everything I can. There's my 8. There's my 10. And there is my 408. Okay, what you see on the right side, us taking all parts of the 12 and multiplying it by the 34 is what we're going to do on E. I just want to put a little bit of a beginning to it. So I'm going to get rid of that problem we just saw on the right. And instead now what I want to do is I want to tackle E like it was a grade 9 problem. So I want us to forget about what we just did on the right, and let's tackle that as if we were walking in out of grade 9. This is us addressing our x times our 2x plus 3. What you know is to expand brackets means that you are going to take everything out in front of that bracket that's attached by multiply, and you need to multiply it by everything on the inside. So I'm going to do that exact same thing with E. It's just that what's attached out in front is more complex. It's 2 terms instead of 1. So now I'm going to multiply that into all parts of my second expression. Okay, what does that give me? Well, when I go and expand my x plus 3 times x, then that would be me writing x times x plus 3. Now, before anybody holds up on that and goes, wait a second, how did he get that? I could have written it this way, the exact way we just spoke about it. But I'm going to bet and say that for most of us, that form looks a little unusual. We're not used to seeing a binomial times a monomial with the monomial second. That general form would say that if you have a 2-term expression times a 1-term expression, then write the monomial out in front. Since it doesn't matter what order we multiply in, this would be the way that we would generally write that multiplication. So there is x plus 3 times x. Okay, now I need to take that x plus 3 and I got to multiply it by the 4. So I'm going to do the same thing with regards to form. There's my 4 times my x plus 3. Okay, you end up creating that gold expression. And I'm hoping we've got some instinct that in order to simplify that, we need to expand some more brackets. So we could take the x out in front and expand it in. We can take the positive 4 out in front and expand it in. And in the end, what we're going to do is we're going to collect anything we can, and that's going to get us down to that expression. Okay, I want you to make a note of what you just saw. There is us taking your background from grade 9 and expanding that x plus 3 into x plus 4. We multiplied a 2-term expression times a 2-term expression. That is a binomial times a binomial. That created what I'm putting your pink star beside. It's an uglier expression, but it's something that's manageable for us. That now requires you to expand some more brackets, and then we collect. And I'm just going to make the argument to you, when we get good at this, I want to go straight to my final line. Okay, I want you to take a look at the screen and make sure that we check out with that we are good, that x plus 3 times x plus 4 is x squared plus 7x plus 12. We can see the expansion just like we would have done up on the right in green and blue. Okay, now what I want to do is I want to get rid of your grade 9 multiplying, and I want to pop back up in the top how we multiply 2 digits by 2 digits. I'm going to get rid of that solution in gold, but I don't want to erase it all. So I'm just going to put a solid line through it. There is my line. I'm not really focusing in on that. But instead, I'm going to tackle it the green way, which is I'm going to take every part of my first value, and I'm going to multiply it by every part of my second. Now, I'm going to go ahead and I'm going to get rid of all those blue arrows up on the question, because I want to make sure that we can see the original expression clearly. For me to multiply it the green way, I need to take the 2 and multiply it by all of the 34. And then I need to take the 1 and multiply it by all of the 34. The equivalent step for me in the original expression is to then take the first term and multiply it by all parts of the second. That would give me an x times x and an x times positive 4. Then I have to take all parts of the second and multiply it by everything. That would give me a plus 3x and a positive 12. And you'll notice we kind of come in on the same line. If I was to now collect everything up, I do find that I've got 2 terms that are like terms, and I can simplify that down to an x squared plus 7x plus 12. There is my equivalent expression, but that's a lot more efficient. That rather than me viewing it as a grade 9 expanding question, if I understand how to multiply 2 digits by 2 digits, then I can expand it quickly and then leave my collecting till the end. Okay, I want you to take a look at that screen because that is how we can multiply binomials. And by the end of the day today, we're going to start stretching that into multiplying 2 terms by 3 terms. You guys are going to expand how ugly the numbers are that you can work with, the expressions, through multiplying. Okay, that was a big problem for us. There was a ton of theory in there. What I want to do is I want to make this a little more mechanical for us now. Let's take a look at the next one. So what you see on the screen right now, you've got 4 different expressions that I've put G through J. All I really want to focus in on right now is G. As I said, I want to make this a little more mechanical for us. And so when we take a look at G, we should be able to look at that and say, hey, I've got a 2-digit value times a 2-digit value. And so if I am going to go through and do that multiplication operation we can see, then what I'm going to do is I'm going to take every part of my first value expression and multiply it in. So there's my y squared minus my 2y. And then every part of that second part of my value and multiply it by every part of the other. And there is my positive 5y and a negative 10. And then that's going to simplify all the way down to the gold where I can collect and get y squared plus 3y minus 10. So I'm hoping that you can take a look at those blue and pink arrows up at the top and see that what we're doing when we expand is we're taking every part of one value and multiplying by every part of the other value. Now that they're expressions, every part of one expression multiplied by every part of the other expression, and then simplify. Okay, before we jump in and we tackle H, I, and J, you may have noticed that question F was missing. And what I want to do now is I almost kind of want to backtrack a little bit. And what I'm going to do is I'm going to challenge you right now. Can we tackle what may appear to be a more difficult problem? Let's take a peek. Okay, take a look at question F. There it is. And so when you take a look at question F, I'm hoping you look at it and you go like, wow, that thing got uglier or got bigger pretty quickly. But I'm hoping that even just with our discussion right now, we can take a look at that expression and say, hey, it's not more difficult, it's just more. Like that is, there is more to do in the expression in F, but more to do doesn't mean more difficult. Even though I'm hoping we can take a peek at that and recognize that we're now stretching ourselves into being able to multiply a 2-term expression by a 3-term expression. So I'm just going to hop off to the right for a second again and just go like, that would now be like us being able to multiply 345 by 12. Like pretty quickly, we're going to vault up to now be able to multiply a 2-digit by a 3-digit. That is great. Okay, I'm going to ask you to test yourself a little bit and see if you would be comfortable, without us ever talking about an expression like F, to go through and give it a shot on your own. Okay, I want you to try it on your own, see what you come up with. Pause the video now. Okay, we're back. So I am hoping that 2-digit by 3, we can kind of see that really all we need to do is like multiply by everything and then multiply by everything. That when we take a peek at F, I'm going to take my X and multiply it by every part of that second factor. So that is going to give me a 3x cubed plus a 4x squared minus a 5x. And then I need to take the 2 and multiply it by all parts of the second factor. And there is my 6x squared plus my 8x minus my 10. So if you have that down on your page, well done, good instincts. That we were able to go through and multiply all parts of one by the other. Now, we take a look at that pink and blue line, and we recognize that there's a little bit of collecting we can do. I have nothing that I can collect with my x cubed. However, I do have 2x squared terms. I can put those together. I do have 2 single x terms. I can put those together. And then I finish off with my constant at the end. So if you were able to work your way through F, great. If we struggled a little bit on F, you can now see your way to work through that more complex multiplying and recognize it's the same thing we did on question G, we're just doing more. So much so that like I hope you guys could see, I could give you like a huge multiplication that you could go through and multiply, and it just becomes a slow, methodical process for us. We take our time and hit every combination as we multiply. Okay, well done on F. What I want to do now is I want to jump back to those 4 problems that we looked at earlier. Okay, so you can see H, I, and J back up on your screen. And I think we're at the point where we should be good to be able to try some problems on our own and start to really build up that confidence. So I want you to work your way through H, okay? I want you to give it a shot. You copy down 3a minus 7 times 2a plus 5. And now I want you to go through and try to multiply that one, okay? Pause the video now. Okay, we're back. This is going to be one of the last ones where I'm going to put my arrows on the top. So maybe we took that 3a and we multiplied it by everything in the other bracket. So when I do that, I'm going to get a 6a squared as my first term. There's my 3a times my 2a. And then a 15a when I multiply those lasts. Okay, and now I can take my pink and do the same thing. I have to take the second part of my first bracket and multiply it by everything inside the other. And now I can go ahead and clean it up to give me my simplified expression. And hopefully we match up. Okay, I'm hoping that this is starting to feel pretty automatic for us. I'm hoping. What I want you to do, try to pause the video and work your way through the next two expressions. And then we'll come back and we'll see how we match up. Okay, pause the video now. Okay, we're back. So let's take a peek at the first one. I'm going to actually get rid of all those arrows now, and I'm hoping that we're quite comfortable to say as a first line for us, I could take my 2x times my x, which gives me a 2x squared. I can now take the 2x plus the 5y, so there is a 10, excuse me on that one. I forgot entirely about my x. There is a plus 10xy. I now have my negative y times my x, so there's a negative xy. And I finish off with my negative y times my positive 5y, and there's my negative 5y squared. Okay, I'm taking a look for any like terms, and I notice that my two middle terms can collect. And when I collect those, I'm going to get 9xy's. And there is my final green expression. Nice. Okay, if we were good on I, then let's keep going along with J. If we had a hiccup on I, then I want you to pause the video again and give J a shot on your own. Okay, otherwise we're going through to check that solution. So we take a peek on J. If I multiply that 3a times the 2a, then there's a 6a squared. My 3a times my positive 7b is a 21ab. My negative 5 times my 2 is a negative 10ab. And if I just slide that over a little bit, my negative 5b times a positive 7b is a negative 35b squared. Okay, I clean it up, and I notice I've got like terms in the middle. That is going to give me a positive 11ab minus my 35b squared, and we are good. Nice. So I am hoping that those went well for you, and that we're kind of getting used to now being able to multiply two digits or two terms by two terms. Nice. Okay, if that is comfortable for you, then I want to have a little conversation about how we can be a little faster with it. I would actually like to go through each of those four problems and multiply those in one step and one step only. Okay, to do that, we're going to have to recognize a bit of a pattern. So what I want to do is I want to go back and look at those same four problems again. Okay, so what you see is G through J again up on our screen. But there's a little bit of a pattern to what we've been working through for those last four problems. That is when we have a binomial times a binomial, and those binomials take certain forms. I hope that you've been able to recognize over the last four problems, or even going back further, that we seem to be able to collect our middle terms. So I'm just going to go ahead and I'm going to put that up real fast again. Question G, all four terms. So when I expand two terms times two terms, I am going to get four terms, of which we notice those middle terms seem to collect. Take a look back on those four problems and notice your middle terms have always collected. Now, it shouldn't surprise us that when we take two things and we multiply them by two things, that we get 4, and you can see that in the green. That is an always. However, the fact that that will simplify down to 3 terms is a specific pattern. We've been able to collect the two middle terms, shrink it down to 3, and I want to discuss why. And if we can recognize why, then you have the ability to multiply those binomials and simplify it all in one go. So what I'm going to do is I'm going to erase everything that we put down in terms of that solution. And I think I can get rid of the pink up top because we know 2 times 2 is 4. What I want you to take a look at when you look at your brackets, your factors, you'll notice that those factors take a common form. You have a variable and then a constant. You can see my variable, I'm pointing at it with the arrow, and then a constant. Look at your second bracket, variable and a constant. Notice in all of the problems, the pattern continues if we remove the whole constant part. Look, I've got a variable with a, and then instead I just go something different, an unlike term. Let's call that b. Well, my next bracket is an a and a b. Can we see the pattern? Look when we jump down to question I. You have something in the first term, x's, and now you have something different, y's. X's, y's. You even take a look at J, and J specifically has those variables, a's and b's. Well, if we follow that pattern through, then what you will notice is when you multiply the parts of the factors that are kind of opposite with your placement, and I'm going to draw some arrows, you'll notice that this y times that -2, and then this 5 times that y are going to create like terms. They're going to give you y terms. Look over in H. 3a times 5 is going to give me an a term. -7 times 2a is going to give me an a term. Another pair of like terms. If I actually go back and with those blue arrows wrote down the 2 terms, then if we are decent at being able to multiply those values and then collect, you have the ability to tackle each one of those problems in one step only. So what I'm going to do is I'm going to get rid of all that blue stuff again, and I'm going to go through and I'm going to talk about how we could expand, so do the multiplication, and collect, the add or subtract, all in one step. So let's take a look at G. Our focus is G. We're going to go left to right and start expanding that. Well, I can see at the very beginning, I'm going to take a y times a y squared. But now, when I go to take my y times my -2, I am not going to write down -2y. I'm going to keep that in my head. Then I know I'm going to get a like term when I multiply the 5 times the y, 5y. So if I take those 2 blue terms, my -2 and my +5, and I put those together, then I can see that I'm going to have a positive 3y. I can collect in one go. I can then finish that off by taking my 5 times my -2, there's my -10, and I can now tackle that problem in one step only. Okay, I'm going to tackle the next 3. No writing down, not even the blue, not even the arrows. We're listening and following along carefully. I'm going to multiply the first term in each bracket. 3a times 2a. So there's my 3 times 2, my a times a. Now I'm going to multiply those outside terms, that 3a times a +5. Well, that's a 15a. Now I'm going to multiply the 2 inside terms, my -7 times my 2a. That's a -14a. Well, if I do my 15a and my negative 14a, well, 15 minus 14 is a positive 1a. I can collect in one go. Now all I have to do is multiply the last part of each factor, and there's my negative 35, and I'm good. Okay, I lied to you. I ended up writing down some arrows. We could be better on the next one. If you are comfortable with what I'm walking through, then I might argue to you, try I and J again on your own, but do it in one step. And really, don't look up at the completed expression when we tackled these problems before. Okay, I'm going to truck through. If I multiply my first in each bracket, then there is my 2x squared. If I multiply my outside terms, well, then there's my 2x times my 5y. That is a 10xy. Then my negative y times an x, well, there's a negative 1xy. My 10 minus 1 gives me a positive 9. Those terms were xy terms. And then I clean up the end and multiply the end, and there we go. Okay, I want to highlight one more thing just in case we're not seeing that pattern. Look on question J. When I multiply my outside terms, that's going to create an AB term. Because the pattern in my brackets, where the first term starts with an A or includes an A, the last term includes a B, when I multiply my insides together, I will have another AB term. My green arrows are going to create like terms. I almost don't even have to think about the variable right now. Watch the way I think about it. Okay, I'm going to multiply my firsts. My 3a times my 2a. Well, then there's my 6a squared. But now when I multiply my outsides, and I have 3a plus 7b, I can see I'm going to have 21 ab's. I'm focusing in on the 21. I know what they're going to be. They're going to be AB terms. Like, I could write it down right now if I wanted to. Now when I multiply my insides, I see I get a negative 5 times a 2. There's my negative 10AB. Again, I already know I'm going to get a like term. So if I'm thinking about the 21 collected with the negative 10, then that's going to give me a positive 11 of those terms, which I can see are going to be AB terms. Now just finish off multiplying on the end. Well, that's the easy part. There's no like term to collect with it, and there we go. Okay, an alternate way through G through J. This is going to be my challenge to you now to finish off for today. Figure out where you're at in terms of your comfort level, and then push yourself as soon as you are comfortable with tackling it one way, try to get faster. So if you are comfortable to expand binomials and get your 4 terms and then collect in one more line, do it. But as soon as you are comfortable with it, you're not making mistakes, there's hardly any hesitancy, then try to tackle it in one step only. If we're not comfortable with the one step, then we got to make sure we get our feet underneath us. Let's make sure that we're expanding it to 4 terms, cleaning up to 3. Please do not hang on to that though. The faster you can get to expanding binomials into 3 terms when it allows, the better off you'll be moving forward. Okay, let's tackle a couple more problems and see where we're at. Okay, you can look on your screen now and you see that we've got question K, we've got question L. Let's use K as our gauge. Numbers are going to get a little bit bigger, so that maybe that makes our multiplication a little tougher. Numbers get a little bit bigger, maybe that makes our collecting a little more difficult. I want you to give K a shot. Your job right now as you work through K, have a goal in your mind. You need to be correct. Do not be worried about fast. So I want you to be 100% perfect on the final expression for K. Okay, give it a shot. Okay, we're back. Just because the numbers are getting a little bit bigger and because we want to use it as a bit of a check, I'm going to go through and I'm going to put down all 4 terms. So we take a look at the very beginning. I have a 7y times an 8y. 7 times 8 is 56, and y times y is y squared. Now I can go ahead and I can multiply those outsides. So my 7y plus an 11y is a positive 77y. Now when I multiply my insides, I can see that I'm going to have a negative 9 times 8. There is a negative 72y. There's my like terms again. And then when I multiply my outsides, or sorry, my lasts, I can see that I get to that minus 99. Okay, clean up whatever I can, and I notice that I can clean up my two middle terms because of the pattern in my brackets. And that's going to give me a positive 5y, and then my negative 99. Nice. So, as I said, your goal was to be perfect. So, I do not care whether you did that in 2 lines. If you attempted that in 1 line and you got down to that goal, then outstanding. But if you made a mistake tackling it in 1 line, I'm going to say backtrack a little bit for right now. Make sure that we're being perfect on those expressions for right now. Okay, what I want you to do is give L a shot now, and I want everybody to give L a shot. So give it a shot on your own. We'll come back and we'll check it out. Okay, pause the video now. Okay, we're back. So if you went through, and I'm just going to go through and tackle this quickly, and you said 8a times 5a is a 40a squared. On the outside, you'd have a minus 56a, and on the inside, you'd have a plus 15a, and blah, 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 blah. If you started writing out that blue, you are so wrong. It is unbelievable. Okay. Why is that wrong? Well, I want you to take a look back at question L, and then maybe we need to take a look at question K and the previous problems to see I changed something on you. Please make sure that we are not putting the blinders on and just assuming we're doing the same thing all day. Your job to simplify that expression is to see the operations that are in there. Can we look back to question K and notice that those brackets on the first term say you are taking 2 things, and the brackets on the second term say multiplying by those 2 things. So you are multiplying the whole 7y minus 9 times the second bracket. Well, take a look at I, and you'll notice those brackets at the very beginning, they're not there. This actually looks an awful lot like question D from today. That notice, if I look at the operations, I have addition right now, and the only spot where I have multiplication is between the 3 in the bracket. The 8a is not attached through multiply at all. So that blue is really bad. So much so, I'm going to erase it, and hopefully you can repress the memory of ever seeing it. Well, I don't really mean that, because I want you to remember that that common mistake we're going to make is to not see. We're not talking about a binomial times a binomial anymore. It's solely the monomial times a binomial. So watch out for that. Perhaps we ended up doing this, and if we did this, then I'm going to say outstanding to you in terms of being able to recognize your operations in the expression and simplify. So hopefully I didn't catch you at all on question L, and hopefully we're quite comfortable to recognize those operations. Okay, now that we've got that under our belt, I want to play with some problems that are going to look the same but look a little different. What I want to make sure we do with the next group of problems is just challenge a couple things. You can see the 4 problems that I've put up on the screen right now, and I'm going to argue to you that I think that I could have put some ideas in your head that I want to make sure you don't make assumptions on. So what I mean by that is I feel like I could have built up some patterns in you, some instincts in you that can be really, really good. But I don't want to put them there so much so that you put on your blinders and now we make mistakes in what we see. So what I mean by that is I think that I could now have built up an instinct in you where you're going to have some hesitancy as you work through the 4 problems on the screen. And what I want to do is I want to kind of pull you back from that restriction, that pattern, and make sure that we're fluent in being able to work with this stuff no matter what it looks like. So let's take a look at M and see what I'm talking about. You'll notice that I kind of moved the position of the variable. that I think I would have a number of people that would be like, wait a second, that looks weird. Like, shouldn't it be like an M and then a number and then an M and a number? And don't worry about the particulars of my pink, but that's what I'm getting at when I'm saying that I'm going to throw some expressions at you that maybe challenge a little bit the pattern that's been built up. So I hope you can see in question M, I've moved the variable on you. Should that make a difference? I'm hoping your answer is no, that you can recognize that, hey, it's still just a binomial times a binomial, and work your way through it. So what you see on the screen is 4 problems that are going to challenge the pattern a little. What I want you to do is I want you to try all 4. I want you to pause it, work through on your own, and then we'll come back in the end and we'll see how well we did. Okay, pause the video now. Okay, we're back. So if we recognized a little bit that, hey, this is just a binomial times a binomial, but it looks a little different, then I'm going to maybe guess that we may have put in a little extra step. What I mean is we could have been comfortable to tackle this in one step, but because it looks a little weird, we may be motivated to go, you know what, I'm going to play this one safe. I'm going to expand and multiply my 2 terms times my 2 terms and get my 4 terms. I'll play it safe, and then I'm going to go through and I'm going to collect. Now, if we write it this way, we are 100% correct. I will argue to you that that is a bad form because standard form with an expression like this is to put that expression in descending order. So when we go through to collect like terms, I shouldn't have my constant at the beginning and my m squared at the highest power of m is m squared. It should go at the front. And now my next power of m, and now my last power of m, which would be no m's, goes at the end. Okay, you take a peek at that, and that's what we should get down to. You'll notice that up until this point, we haven't really had to consider that because the form of the original factors was always being expanded and therefore put in a descending order. Okay, we take a peek at that. Make a note. The most common mistake you are going to make is when you multiply those together, you end up getting a negative m squared at the end. Be very, very careful. Remember, your negative times your negative gives you a positive. Okay, we should be good to work through. If at any point you need to pause the video and try them on your own again, please do so. Okay, I'm going to keep moving my way along. And maybe I do the next one in one step. I can see that my brackets take a pattern, constant and a t term, constant and a t term. So when I go through to expand those, I should be okay to be able to see that's going to give me a t term. That's going to give me a t term. I'm going to be able to collect. So I'm going to do it in one go. Now, when I go through and I expand that, I'm going to now get a positive 20. My top arrow, when I multiply my outsides, is going to give me a negative 15t. My insides is going to give me a positive 8. Well, negative 15 and a positive 8 is going to collect to a negative 7. And now when I multiply my variable terms, I'm going to get a negative 6t squared. There is me expanding and collecting in one go. You'll notice, though, that that's going to give me an expression that's in bad form. So I'm going to put that in descending order. And maybe for some of us, that's the way that we take 2 lines now. For others, maybe you're going to do what we did on M, and you would expand to 4 terms, but then collect and put it in the correct order all in one. I think both ways are pretty efficient. What I do want to draw your attention to, do not write in the expanded form of those 2 terms, as I just did in blue, as part of your solution. Guys, if you need to write down the blue, then you should be showing all 4 terms when you expand. If you have to write that down on your page, even as rough work, then you should be expanding it to 4. I would consider that bad form to include the blue. There's no harm in just putting in your 4 terms then. And then we just keep working over time to not have to write that down. Okay, something to keep in mind as we move forward. Okay, I'm going to jump into a solution for O. We work our way through O. Well, this is actually a really nice one to work with, because you'll notice my first bracket has an X then a number. My second bracket has a Y then a number, or a Y then a constant. I recognize that when I go to expand those brackets, I will not have any like terms. Because my brackets don't take that form where I would have a like term within it, I will not have a like term when I expand. So when I go through and I expand, X times Y is XY, 3 times X is a 3X, 2 times Y is a 2Y, and 2 times 3 is 6. I can see I have nothing to collect. I am fully simplified for that expression. Nice. Okay, we got one last check. You take a peek, and I think we should be okay. We will not have any like terms, so now we're just slow and methodical, and we make sure when we expand, we now have our final simplified form. Nice. I think if you were able to work through those 4, I don't know if there's going to be anything in your practice today that I could throw at you that's going to jam you up. However, I do want to throw one more kind of stumper at you a little bit and give you a chance to kind of play with something as we work our way through. Here we go. I want you to take a look at question F now. There's our expression in Q. When you take a look at Q, you will notice that I just significantly changed what we have been doing today. I didn't necessarily make it more difficult, although some of you may disagree with me on that one. I think I just made it more. If we are good on a 2-term expression being the same as a 2-digit value, then maybe what I just did is I asked you to take 12 and multiply that by 34, and then multiply that by 56, and you start to go, oh my goodness, that number is going to get huge. And I might go, yeah, it might get big, but I think if we can recognize that what I asked you to do in Q was what I just wrote on in green, then you may have a methodical way that you could work your way through that would enable you to go through and get that solution. If the green is so difficult when we look at it, and it is, like that answer is going to be big, then maybe you could slow it up and shrink it down a little bit to, well, is that any different than just a 2 times a 3 times a 4? Make the numbers more simple, which enables you to work through a strategy. So I'm going to leave that up on the screen for a second. I want you to give Q a shot on your own. Okay, here we go. Pause the video now. Okay, we're back. So if you took a look at Q and we can recognize it as 2 times 3 times 4, it is like 2 multiplications. I'm taking 3 things and I'm multiplying them together. Then a way that I could go through and multiply that would be multiply your 2 times your 3, see what you get on that. Hey, 6. Now you just have to calculate 6 times 4. With the uglier green numbers up on top, then maybe you're going to multiply 12 times 34 together first, get your answer, then multiply the 56 by that. So when we take a look at Q, really what we want to do is maybe focus in on one of the multiply operations first. So I just put in some square blue brackets there. Those are never required, but I think it just gives you a nice visual on what we're going to calculate or simplify first. So my first line, and I would recommend putting both of these in for our solution, would be I'm going to multiply my firsts, which is my a squared. Now my outsides give me a 2a, my insides give me another 1a, so that gives me a 3a. Multiply my constants, there is my 2. I'm going to get rid of those gold brackets. I hope we don't need them anymore. And we just got to a case where you took your binomials and they multiplied to give your trinomial, your 3 terms. So now we need to multiply that by the remaining a plus 3. Okay, this becomes the rub. I hope that you can see that what you just wrote down, if you wrote down that gold, is incorrect. And the reason why, I'm hoping it's screaming at you that we have not included the full multiplication operation. Right now, that goal just says that you would take the 2 and multiply it in. And if you go back up to the original Q expression, we need to take all of that and multiply. So we need to ensure that to keep that multiplication operation correct, we still need brackets around that a squared plus 3a plus 2. Now we have what we need. Okay, how would you choose to go through and multiply that gold? Well, perhaps you're going to take that a squared and multiply it by everything, and then take the 3a and multiply it by everything, and then take the 2 and multiply it by... Maybe that's the way I'm going to take my 3 things times my 2 things. Or maybe what we're going to do is we're going to take the 2 things and multiply it by the 3. So maybe we're going to take the a and multiply it by everything, and then take the 3 and multiply it by everything. It doesn't matter. What's 2 times 3? What's 3 times 2? In either way, we're going to get our 6 terms. So let's go ahead and let's expand that to 6 terms. If I've caught up to you, pause the video now, give it a shot, see if you can finish it off. Otherwise, here we go. I am going to take my a squared and I'm going to multiply it into my shorter bracket, my binomial. So I'm going to take my trinomial and multiply it into my binomial. So my a squared times my a is an a cubed, a squared times 3, 3a squared. Now I'm going to take my 3a and multiply it into everything. So there is my 3a squared plus my 9a. And lastly, I'm going to take my 2 and multiply it into everything. And there is my 2a plus my 6. You'll notice there are my 6 terms that I got when I expanded it. Now I can clean it all up into my gold. Nothing to collect with the cubed. I do have 2a squared terms. I have 2 single a terms and my constant. Very nice. If you were able to work your way through Q, then that is outstanding, and you are well ahead of the game in terms of getting comfortable doing this new multiplication. Your job now, jump in and get your practice and make this so that you can work through that multiplication process with like little or no hesitancy. You do not want to hesitate at all. That's your job. Jump in and get some practice. Best of luck.